Sorry if I just hurt your ears. Okay. We are going to look at a variety of calculus type things with our vector value function. I want to go back to our concept of a smooth curve. If we have a vector valued function, where would our curve not be smooth?
When they equal each other. When the points are this, like when they're
both
the same,
zero.
like when they solve for zero and they have the same.
Okay. So we would be smooth everywhere except when r prime of t was the zero vector. So both the x and y components were zero, right?
That's zero.
That's a zero vector. So 0I plus 0j. So bold it. Okay. For example, here I have the vector valued function. The quantity t plus sine of t, I, plus the quantity 1 minus cosine of t, j. Why did you say that?
Because it's going to have zero at the same time somewhere.
You think so?
I think so.
Our derivative. The derivative of our horizontal component. Anthony, give it to us. And the derivative of our vertical component. Caleb.
Sine.
He had an inflection in his voice like he wasn't sure, but we have confirmation. We're good?
Yeah.
Okay. So if I want to know where this dx dt essentially is 0,
That double cosine t is negative
which happens when?
pi.
And 3 pi and 5 pi and right? Every 2 pi,
Sure.
it's going to happen.
Well, every 2 pi starting at pi.
Thank you. When is the sign equal? Oh, and I'm putting x. This needs to be a t. When is the sign equal to 0?
Pi,
Zero. It's
Zero.
pi, pi.
All of the pi.
Oh, all of them. Yeah, but I was listening to one.
Not the pumpkin.
Every pi. Cherry pi.
You said all the pie, and I said not the pumpkin, and then you didn't get it. Okay.
I get it, and I thought it was really funny.
Uh-huh.
So funny. I didn't laugh.
He's laughing on the inside. He's almost crying.
Okay, Dave. Okay.
Okay. So this curve is not smooth when t is pi plus 2 pi n, right? Because here we have all of those overlaps. Okay. Now, what's happening at 0 and 2 pi and 4 pi and every even pi?
It's the y derivative is 0.
It's horizontal.
So horizontal.
Okay.
I thought I've seen this somewhere before. Like, didn't we talk about this?
Yes.
Like at some point?
Yes, like last week.
Is it called cycloid? Is that what? Is that? I think I might be thinking of the wrong thing.
This one?
Yes, that one.
Yep.
Awesome. I remembered the thing. That's a first.
I forgot it.
Okay, so if I'm going to take the antiderivative derivative of a vector valued function, then we would take the antiderivative of the horizontal component and the antiderivative of the vertical component. I hope you have your bold font ready. Now, I was not able to bold what I needed to bold in this because of the font I was using couldn't be bolded inside of the just go ahead.
I wonder how Richard's
Oh, the
gonna be
bug's over
able
here.
to live with this.
Oh, okay, good.
Well, now it's at least not over anyway. If I had a fly swatter,
How do you know it's a he?
does somebody want to take him outside?
Yeah, I'll take him outside.
At the end of the hour, you'll be in charge of taking the lady bug outside.
Actually,
I
it
think
might
it's
be a
kind of
little
nice
cold
having a
outside.
class pet.
Keep it inside.
I'm gonna keep.
Yeah.
I'm gonna let it stay.
What do we feed this?
It's gonna be
dog?
60
I don't
degrees
know.
today.
People? What do
All that
ladybugs eat? I don't remember.
Infiltrate the building, get all the way up there, and then Richard's just like,
Actually eat other bugs.
Aphids.
Example, write it down.
Cool.
Ooh, that's
It's a rough one.
I know it really is.
glad you
You doing okay? Where are you? That's really disappointing.
agree.
Well, it just sounds like you're a little upset.
Like we can always just assume that.
You know, it could be me.
I don't know if you're talking about I'm always.
Okay, so according to what we just wrote down, we can take the integral of the horizontal component, I, plus the integral of the vertical component, J. Okay. Now,
Honestly, I don't like qualities.
Matthew, what is the antiderivative of e to the t?
Would it be perhaps e to the t plus c?
Oh, you remembered the
well,
plus.
I think it's e to the t minus c.
Are you even sure it's a C? Like, what if it's an A?
I mean, whatever letter you choose for the constant.
I chose c sub 1. Why did I do that?
Because it's the first one.
That's not my only plus c. Okay, so Richard, my antiderivative for sine of tj. Do you notice how my constant is like with the j? And with the I. Okay, so essentially what we have is the vector valued function e to the t I minus cosine of t j plus a constant vector. C1i plus C2j. Do you understand where I'm getting at?
I don't know where you're going with this, but I understand how you got this far.
I'm
So I feel
stopping
like
right
that's.
here.
Oh, that's it.
Yeah,
Oh,
I mean, technically, we don't know.
it was an indefinite integral, so we have no other place to go.
okay.
Okay.
What if it wasn't?
I actually don't know. I don't want to ask.
What if it wasn't?
It's radians until
Is it radius?
it's degrees.
Write down this example.
So e to the t is what?
Nothing. It's not either one.
It's not great.
But when you're plugging in values to graph it, would
It
be
doesn't
radius?
matter because it's not a trig function.
But just to be safe.
But cosine is a trig function, so that would need radians.
Unless you're
Wait,
It doesn't make us.
so when do we know when it's degrees then? This isn't all like trig if we're dealing with angles or But when would we know when it's degrees again? Like, isn't it always straight different?
Like, it's always radians. I would assume radians unless I give you something that I say, find this in degrees. Or this is a degree measurement.
Okay.
And then you have to.
Okay.
Okay. If I know r prime of t is 2I, and we want to get to normal r, the function, we need to do what? Take the antiderivative. So, r of t is the antiderivative of r prime. Right?
I would assume.
Okay. Now, our antiderivative would be, please be careful,
2 plus c.
Let's see, 2J.
plus we could have a constant for j.
Just like
You just like that?
It's tricky. I don't like it.
That's how it goes.
Well, like the antiderivative of 0 is a constant.
it's tricky.
That's just the way it is.
Okay? So now we know that r of 0 is the vector 1, 1.
We need to find c. Sorry.
What?
We need to find c.
Exactly. So,
But are those two
Just
C's
trying
the
to
same?
switch.
no.
That's why there's
Yes.
Which is why we need to use this. So if r of 0 is the vector I plus j, what is
This
C2?
example.
It's gotta be 1.
Okay. This
Oh.
constant needs to be 1 because of this stipulation right here. Now, if our horizontal component is 1, when we plug in 0, what is C sub 1?
I gotta say 1.
Okay.
So the C's both the same.
They are in this example. Okay. So now we know that R of t is 2t plus 1I plus j.
What happened to c?
It's now a number.
We found it.
C equals 1 plus 1 times anything.
Oh shoot, I
What
gotta check
happened
the
to
loss
c
and
and
found
j?
for that one.
Oh,
What's 1 times anything?
Not for the money, but for
Wow.
the license.
Oh, I assume if
Fields
someone
done
plugged into
times-
loss and found they took the money.
Okay.
I just need the license.
One last example, and then you will have 25 minutes to start, maybe finish your assignment if you want.
Dip
What a
them on
time
the
to be
books.
alive.
We finish our with
Please just let her go. Richard, you want to grab me one of the books, please?
We are going to do the fundamental theorem of calculus, but with a vector valued function. It's not any different. Okay, now I did change it up a little bit where I'm using a vector instead of like that. Well, our vector value function is in component form as opposed to the i's and j's. It's fine. We're still doing the same thing. It's still a vector value function. Okay.
Why not just convert it to J's and do the exact same stuff? Like if you can, well, why not just convert this to I's and J's and do the exact same stuff?
You can.
That's exactly
So-
what
Okay.
When we do the fundamental theorem of calculus, do we need plus c?
No.
No, because we have a definite integral. So the antiderivative.
Oh wait, no, that's the it's where it's like that minus that and then you
What's the antiderivative of 1?
T.
Gotta go with T.
And then the antiderivative of t.
1 T squared.
Evaluated from 0 to pi.
Right.
The arrows on
That's
the
what I
side
got.
and the eyes in the middle.
I forgot to ditch the letters, you are correct.
Yeah, don't combine them.
Oh, yeah. Like
Okay,
I have a question.
so, yes,
Okay, so, because the bottom number is a 0, it's just a little hard for me to see, but would you if you were trying to subtract the bottom number from like the top one, would you like,
No.
would you do it for each individual one, like,
I would do vector minus vector
Singular book.
to get your answer of vector.
okay, I think I get it.
Okay, plug in B minus plug in A. Alright, so you have the next 25 minutes of class to start, and I'm going to challenge you to finish your homework assignment.
Why would I need both?
He's gonna finish. It's a worksheet.
We need to get the calculus under control
Wow.
before we start talking about velocity and speed and all that stuff
Do you
tomorrow.
want to read out the numbers?
It's a worksheet.
It's a worksheet.
Wait,
Yeah.
it's a thing. And like, trying to make money and like, there's so much money.
Would it be cool if I got the math assignment done?
Oh yeah.
Kind of the same